Hello, hello. Hello. Yep, yes. So I'm audible, everyone. So I'm trying to learn SFML game dev, other than web dev and backend and everything. I thought of learning new things, so best I found is game dev. I'm learning SFML, not Unity or anything, but I want to brush up with my um, C++ also. So I was watching tutorial and actually I did I used to learn SFML few months back, so I'm taking reference from it and also from tutorial and their official documents. So start. Let me show you what I have. So I don't know, I'm just building random things. So this is the store. Click on screen, a ball will appear and it will bounce down and then again up and then again like you can see counter is increased and then you again click here so it will you can drag the ball and move on the top then again yeah, does that and do these things. I don't know. I'm just learning random things. Not sure what to do. When you right click on it, it will disappear. So let me explain you guys what I did. So basically, I created a ball structure that will have shape, a velocity, the velocity of the ball, and is dragging. This is to capture like if I have clicked on ball or not. Then if this is a constructor, we can pass x and y coordinate that will be set the position. And then radius and fill color are default. I have the global constant variables like gravity, the how fast it will go down, like to the bottom of the bottom line. Then damping is like how much energy it will lose after one repulsion from the bottom. Then ball radius call the ball. Then this is the window with I'm using SFML3. Then I'm going through documentation and my old code. My old is in version 2 and new is version 3. So I'm just taking reference from all this and also I'm new to C++, so I'll also learn more. Not new, I used to do, but I stopped doing it. So I'm sort of new. Then setting up the frame limits. This is the fonts. Setting fonts. I downloaded this from Google pop-in font. Then created a text. Text requires font, so I had to add that. Then balls count, fill color and characters. This is the font size you can say. Then this is the ball vector that will hold all the balls that I knew at. So when I click on this, a ball struct is created and that is pushed to this ball's vector. Then this is to capture the selected ball. So when I click on this, selected ball is a pointer to this ball, which is inside this ball's vector. Then this is the event loop, full event. While is open, while window is open, we do all the things. While this is full event, let's see the function is non-blocking. If there is no pending event, then it will return a null point. Null point. Note that. Let's see, I forward actually. Function used to check for pending event from the window, like a keep full press, mount in window, or focusing. Okay. So this is for like I'm assuming for keyboard actions, mouse, and anything related to that. Then here we are checking close event. If the close button is clicked or escape is clicked, so window will close. Then these are the custom mouse events. So on mouse button, so we have function on left click and on right click, and then we also have left and drag. So mouse release, and then here you can see it is on the left drag is selected ball and is button pressed. So means if the ball is selected and it is dragged, then we are performing some actions here. Then then this is outside the pole. So this is outside the pole. This will be attached to all the balls that we see on the window. So if it is not dragging, means we haven't clicked on it and it's not yet dragged. So what we do is we get the ball velocity. Initially it will be zero. So if I comment this out and run this function again, run this script again, you can see it will be stick to that location. So this adds gravity, means for each frame this much gravity will be applied to that ball, and after that we are getting the current ball position. Gravity is applied, then we have to move the ball from current position to next position. So we are getting the position, correct me if I'm wrong. Then we have the position, and then we add that velocity because this was the old one and we are adding it to the new one. Means if it was 1 and then we added 1.8, maybe what was that, 1.8, then it will be 2.8, and then we are adding to existing one. And then we check if this ball is not yet, so if we click on this window, a ball will appear and it will bounce bottom because we are adding a velocity to bottom, y direction, because shape has x and y. So we are adding y and we are increasing y with this gravity value. So we are checking if it is touching the y axis or not. So if it is about to touch the y axis, what we do is we get the window size. This is to avoid some, I don't know, I did Google and everything. Then ball radius, so we are checking if position y is to the bottom of the window. Then what we do is we reverse the velocity. So you can see if we click on this, it bounced back. So this is why, like suppose it is 2.8 in the bottom side, so if it is touching the bottom, then we are doing negative 2.8. But we don't want negative 2.8, so like it will always bounce. So if I remove this and run that again, the ball will never stop because we are not we are not adding some friction. It will always bounce at the same height also. So to add some friction to it, we are adding this damping value. What damping is, just it will reduce, like it will remove some energy from it. So what we are doing is we are keeping 80% of its energy. So we are taking 0.2% of its gravity or velocity, and then we are setting up the position. Then this is the clear window there. Then we are showing this text. So for that I am using text stream. I just learned this from another tutorial, and I was referencing this code that I have from old one. You can say it is like might be like 7 8 months back. And then window draw, this is to draw all the balls. Then we are drawing that text window display and deleting it. So now what I want is, we have this window. So let's add a value to this guy to differentiate. I don't know, I'm just building random things with codes. I'm going mute for some. Hello, hello, how are you? Hello, bro. What is your opinion on using AI as a tool in research? Yep, using AI is good. If you know what you are doing, then it's good. If else you are like just blindly copying it, then it's bad. I use AI a lot for my office work, for personal research, making like planning, suggestions, and everything. It's good to have like AI, but not to rely on that. Hello, Josh. Bonjour. How are you? Already best. It's already best. How are you, Jashpal? I do this. Nice, nice, nice. Let's see if I pick this and catch this one. This is one. This should be zero. This is two. This is three. One, three, four. So ID is added. Nice. Before that, we break this into classes. Thank you, Pal. Should also join me. We can collab and start. You might have a lot of ideas on games. Let me do this afterwards. I know we have that. Okay. I put a keyboard. We right click on it. Let me see that. So let's check if two ball are intersecting each other or not. Okay, you can check that here. Check if balls are colliding each other. So for that, what we need to do is check all the balls. We have shape. So we can mark their position. Putting the first and what I can think of. So let's get to all the balls. I plus I. This will be outer. Okay, what we can do is these are two balls, right? So if shape palms are within two within close to each other, I mean, right? If we have this to get position, so what we can do is um, let's say A or B. If let's get position. A dot shape dot get position. A position J bound last time. Okay, so it's vector now, so we have to do this. Then how we can that should be flow now. That sound was from my Pomodoro. So this will hold the address of the state. Right. Direct definition of polling reference a position, a position is for now let's log this right. A lot of logs, but okay. Uh, position x a dot position a position dot x. If they are coincide, like they are colliding, We need to find the distance between them. Right. Uh, so for distance, so suppose this body is here, this body is here, right? And this is moving in this direction. This is moving in this direction. Uh, we need to find distance between them. Yes, and this. So this will be this guy minus this guy. We from chat. I don't have idea of this. Um, shape is how an vector of this shape. How can I check if both of them are colliding each other? Plus, depending upon the type of the shape they are using. So depending on shape, if they have a vector of pairs that you want to them, you would look through the vector and check each pair. Example, first you need to check if those specific shapes are colliding. For instance, if you are dealing with a circle shape or rectangle shape, you can use a built-in Boolean method. So they have their nice. For circle shape, you can get use global bounds to check it for rectangle takes collision form. We are getting divide dx and dx. I remember we used to learn this in college time, maybe school times. This is one dimension, two dimension, and point. Other representation given two points. First, we will have these 2 points. Left of the transform. From started in college, they found Pythagoras theorem. Therefore, Pythagoras given to objects that are not points is usually defined the smallest with most public formulas formulas are known for computer distance with different types of objects such as distance from a point to a line. Distance is p minus q distance is equal to that if we get p minus q square root of p minus q square distance. The more okay, so we have this point p minus q. So we have here 2 points. So one dimension. So this is again is one. So what we can do is get the delta point, the distance between the point in real dimension their absolute difference. Thus, if P and Q are two pointless real lines, then the distance between them is given by the sum of our formula given the same value is P minus Q. First, we need to have vector. You have this big float that is A position minus maybe B position minus A position, A position. Then we have the value distance should be this. Uh, this is 2D, so these are both. So we have our game is 2D actually. Friday effect. So we the dimension formulas new to me. If match is nice, but nice you are watching this. Thank you. Here we are getting its vector. find intersection. Let's see, let's try with this. But I remembered learning that checking if they are actually colliding. Distance. Distance is less than all the radius into diameter thereafter, and distance is greater than gap. Here means all these two guys are colliding each other. Okay. So for now, let's just draw what balls are colliding. A dot id have space b dot id, then just see not getting any distance is less than. That's what next. That is for this step. Just this a dot id, then b dot id. We are not getting any dots. So let's log this trial from top. Nice. So they are getting log. So this is working fine. We get delta a position minus a position. We find the distance. Let's find distance. And between this, here will be distance. Call one, call two, one, one, zero. Distance is zero. Why distance is coming zero? First delta y should be J max. distance is 0, again distance is 0. Should be I, but not 1. It's checking for 1 and 2 only. 1 and 3. But I'm doing and sorry. That's the distance is 0. Distance is this. 5, 3. For them, we should get some 0. So here we are getting this. Means they are colliding. So if they collide, then we need to throw them apart. Right? If this guy here, this guy here, this is coming from this direction, this is coming from this direction. We will have to find the angle from where it will be reflected this direction or maybe this direction, and this guy will be to this or this. And then if they collide at this angle, then I'm following this course dependency. Cos dot velocity v dot velocity minus a dot velocity will get us a relative velocity from them. Right? So here we have delta and here we have distance. calculate, so we need to just calculate the normalized direction vector pointing from B1 to B2. Okay, let's see. Get normal direction distance. We have relative velocity between them. So them and the normal is calculated normalized direction vector pointing from ball 1 to ball 2. This is the normal. This is the vector that points from ball A ball to B ball. And this is the relative velocity between. Now ensure that if then relative velocity is the same direction as normal. Just find the difference in velocity between the two balls. The balls are moving towards each other. Now what we are doing here is we have it's moving towards each other. So we get the speed of them. Relative velocity. So I don't know what I'm doing. So push this. We can discuss it together. Why and not we have a speed. This speed it represents the direction of the original vector without considering scale or length. To normalize a vector, you divide each of its components by its magnitude length. So we are creating vector for this and normalizing it to have a point in the same direction. Normalization vector direction vector is a vector that points in the same direction as the original vector but has a magnitude length of 1. Yes. Then speed, if speed is less than 0, that means they both are not. Speed is negative, means it is less than 0, means they are not, their combined velocity is less than 0, means they are far apart. So now they are colliding with each other. They are close to each other. So what we will do? A dot velocity minus equals to normal. Let's see what it is. Speed A starting. That's saying the program is already running. Right. Refresh that guys. I don't see. What is the right thing? Reboot, reboot fix the error similar to. I need to reboot it then. Let's try. Let's restart this guy. Nice. Again we have this error. I have to restart my system then. Let's see. Let me restart my system and we'll be back. Thank you. Have dinner also. So let me start at 11 or 10:30. Thank you again for